Hello everyone. Welcome to the webinar on leveraging computer vision in appraisal workflows. We are glad that you could join us today.
Before we get started, I wanted to give you a quick overview of the agenda and introduce our panelists for today. We will be starting off with areas that we see tremendous potential of computer vision in the real estate market and with emphasis on the appraisal world. This will be followed by a demo of how computer vision has been applied for auto labeling and auto ordering of images. We will understand other areas to apply computer vision, such as enhanced comparable scoring and selection, property data enrichment, and so on. At the end of the presentation, we will do the Q&A session and share details of how to access the webinar collaterals. It is my pleasure to introduce our panelists for the day. Dr. Umesh Harigopal is the CEO of PropMix.io LLC and Managing Partner and Chief Innovation Officer at Innovation Incubator, Inc. He has more than 25 years of experience in cognitive science and financial services and has worked with Freddie Mac, JP Morgan Chase, Citi, and Dow Jones. Danny Mancino is VP Data Solutions at PropMix.io LLC. He has more than 30 years of experience in the US real estate market in AVM and portfolio valuation. He has worked with First American, LPS, CoreLogic, and Digital Map in his previous stints. We expect the presentation to be around 40 minutes, followed by Q&A for 10 minutes. During the session, please use the chat option that you have on your panel to ask your questions. We will cover these questions at the end of the presentation during the Q&A session. I think we're all set to start the webinar. Over to you, Umesh.
Great. Thank you, Sakir. Thanks for the intros. And by the way, I'm not sure if Sakir introduced himself. That is Sakir Hassan, and he's our VP of Product Management at PropMix. And welcome everyone to the webinar, and good to meet you all virtually. And you see, we have actually made a bunch of presentations before at various conferences such as Inman and RESO, etc., regarding various technologies that PropMix has been putting out in the market. But this is our first online webinar as PropMix as a company. So I want to thank Sakir for putting it all together and enabling Danny and me to present today to all of you. Thanks, Sakir. What we're going to do is, between Danny and I, we will kind of tag team today to cover both the business and the technology sides of computer vision. And we'll mainly focus, like Sakir said, on appraisal and appraisal workflows, right? There are various applications for computer vision and real estate, but our focus today will be mostly in the appraisal world. Yeah. And so let me first, before we get into how we use this in appraisal world, what we want to be able to show you is what we are doing with computer vision in PropMix. So we see it mainly from the perspective of real estate. We primarily see computer vision in three major areas, right? First is image processing and enhancement. The main purpose here is to improve the quality of an image before we start using it for anything else downstream. When I say downstream, that would be using the images for powering an IDX site or getting into more of the image recognition and the scene augmentation kind of capabilities, right? Which we're going to talk about a little bit more. So we use many different proven algorithms. These have been in the market within the image processing industry for a few decades already. These vary from filtering out noise from an image, and also in the process, you're improving the quality of the image, right? Some of the effects of such image processing include removing the blur, like the example that you see here. You can run a bunch of filters to make an image less blurry, and also we can improve the brightness or increase the contrast in an image, etc. Right? All of those things are considered image processing, rather. But as you all know, most of this now happens right on your cell phone, right? It happens on your digital camera. The cameras and the cell phones have built-in algorithms for this. I take a picture in my Samsung versus my wife takes a picture on our iPhone. I always feel the Samsung pictures are much better than the iPhone pictures because they have a few more algorithms to kind of take out those blemishes on my face and make me look better, right? So these kind of filters are already happening right at the point of capture of photos. On the other hand, when we do take pictures indoor for real estate purposes, we see a lot of those pictures are pretty hard to shoot because there's so many other light effects. There's too much light interference coming from a background at the window or at a door, and the picture becomes of much lesser quality, right? And so we still see professional photographers are needed to take some good quality real estate photos, right? On the other hand, when we do get pictures which are of poor quality, we have the option to use image processing and this enhancement option to improve the picture quality before it is ready for consumption for image recognition and doing more higher level activities on that image, right? But we also see that just this capability alone is valuable for like FISBO sellers who want to take their own pictures, improve the quality of their images, and then post them on IDX websites, right? So or put them on their local MLS, right? So there is other uses of this, but for today's conversation, we're going to focus more on improving the quality of the image so that we can do more higher level activities on that. See, in addition to that, improving quality, we also extract a lot of metadata from the images. Metadata includes date and time, location information like lat long, etc. These are very useful also to make sure that we're able to match up images to actual property addresses where possible, right? Those are all certain validation steps that we can take and ensure that the picture has been taken in the last 1 week for a particular appraisal, right? Things like that. So there are other purposes for that metadata that we can make use of. So it is valuable to extract that metadata as well. And then once this image processing and enhancement is done, the next step in the process is to use these images, use this cleaned up, higher quality images to do higher level inferences from these images, right? And that is the step our objectives here are classification of an image, object detection, and object recognition. I'm going to talk about those three things very quickly. Image classification is the problem of understanding if the image is showing a family room, or is it showing a restroom, or is it the front of the house or the backyard, etc., right? So that is the core problem of image classification. And then object detection is the problem of understanding the contents of these images, right? So I want to know if I'm looking at a couch or a table, or is it a washer dryer, are there wall paintings in this image, windows, doors, etc., right? But then these two things, image classification, and object detection, kind of go hand in hand, right? Because an inference is made about the class of an image, right? When we make that inference, we use two pieces of information: the overall image, and then the contents of the image as well. So if I know that in this particular room, there is a couch and there's a fireplace and there are two additional single seats here, then that means most probably this is a family room, right? But there's also a global view of this picture based on which I can make an inference that this is a family room. There are other aspects of the image that kind of can be purely trained to know if it is a family room or not. And similarly, once I know it's a family room, I also know that I'm expecting only certain objects inside this room. I'm not expecting a washer dryer in a family room. I'm not expecting a refrigerator in a family room, right? So using the information that this is a family room, we get to make better inferences on what objects are there in the room. So that's why these two things kind of go hand in hand, and we use that information efficiently to better identify what image we are looking at, and also better identify what objects we are looking at, right? We'll talk about that on how we do that further down in our presentation. So once we have done classification and detection, the next step is to really know what object am I looking at. That is the object recognition part. Some good examples of how object detection differs from object recognition is knowing the difference between a restroom sink versus a kitchen sink, right? For example, or looking at a countertop and knowing that it is a granite countertop versus a vinyl countertop, right? Or, for example, in this particular picture that you're looking at, you see there is a bookshelf, but I want to know if that bookshelf is actually a built-in feature of the home that will convey during a sale to me, or is it a part of the furniture that is not going to come to me along with the home, right? So the value of the house depends on what is built in and what is not. So it is important to recognize what kind of objects we are seeing that will kind of make a difference in terms of enriching the information about that particular home, right? So that is image and object recognition. Once we do this really well, we get into a situation where we have all the information to be able to augment a particular image. Either when we think of augmentation, we think of adding new information or potentially removing some information from there, right? And so removing is a much harder problem than adding things into an image, right? Because when you remove an image, what do you fill it with? So I need some continuity in the background, light effects, everything needs to be in place to be able to add or remove things, especially to remove things. But then adding objects is mainly understanding the 3D model of that particular image so that we can augment that image with the right another object in the same perspective, right? So we see adding or removing information versus objects, right? Information is a lot more straightforward, meaning I can easily add some hover over data while you're looking at, let us say you're using an iPad or something to pan a kitchen. If the refrigerator comes into view within that image, we might be able to hover over and provide some additional information about the refrigerator, right? I mean, this is the model of the refrigerator, this how old it may be, et cetera, as opposed to actually replacing the object with a different object. So there are various use cases for that as well. You would have seen already IKEA and even for example, Wayfair. They're all exploring capabilities to provide consumers ways to experience their homes, their family rooms with IKEA furniture, or their homes with Wayfair furniture, right? So to visualize that before you go by, right? So those are some applications of this technology. Just wanted to take a quick moment here to show you some of the capabilities that we have done with augmented reality. This is an example where I hope I can actually show this video reasonably well here. Let me try this. I'm going to pull this up as into this view, and hopefully you all can see this. So here is a short video of what we have done in the past with augmented reality. So this is showing an advertisement of an apartment building that's for sale, apartments for sale, and quickly assuming that somebody looking at this particular advertisement, they read a message on the thing that says, you can view this using our app that you can download from iTunes or Google Play Store. And I download the app, and now if I start viewing the same advertisement using that particular app, then the app will recognize the fact that this is a particular building, and we're able to pop up a 3D model of the building right on top of the newspaper that they're seeing. So this video recording that you're seeing here was recorded using that app that we had built using augmented reality, right? So now you get to open a door and walk into one of these apartments and see the inside 3D model, which would be powered by folks like Matterport, et cetera, in the market today, right? So that's an example of augmented reality that we are working on. Let me continue here, and also want to take a moment to show you all some of the market players that we see in this market. We see this primarily in three major areas: image processing, libraries, image recognition platforms, and AR/VR platforms, right? The libraries are mainly things that you actually build into your code, and these are a lot more lower level capabilities. The platforms are slightly higher level, which help you do object recognition, etc. And AR/VR platforms are evolving quite rapidly in the marketplace today. We are doing a lot of experimentation with capabilities such as Oculus and Microsoft HoloLens. Magic Leap is at the higher end in the marketplace. They have raised billions of dollars for their company based out of Florida. And Magic Leap and AR goggles or the AR glasses from Magic Leap cost you about like $3,000. Oculus is about $300 to $400 with much lesser capabilities than a Magic Leap. And a Microsoft HoloLens kind of falls somewhere in between. We also think that Apple and Samsung hear a lot of rumors always that they're in the market as well to release one of those devices pretty soon. Let me, at this stage, maybe hand over this to Danny to talk through some of the capabilities of what we are building, to just show an example of what we are talking about here.
Hello, everyone. Good morning. Good afternoon. I believe from what I've seen on the registration, many of us have already met. So it's good to talk to many of you again, and those that I've not met, nice to meet you. As Umesh was talking about all of the different capabilities that we see with image recognition and computer vision, some of the items that we've been focusing on as our products and services evolve are how we might be able to offer solutions for appraisal quality reviews. One of the things that we've found from conversations with customers in the past is they want to be able to easily and automatically identify that the necessary photos that are required from a lender are in fact included in the appraisal application, the appraisal order that's passing through the system. So we've built some technology that give us the ability to actually identify and tag the images as they're passing through us, and identifying those photos that somebody might be looking for. So we all know that the front of the home is important. Down the street in either direction is important. Certain photos of the inside of the home are vital. So we have the ability to actually identify those property images, whether they be uploaded by the appraiser or the inspector, or whether they be images that might be coming from an MLS listing. We can look at those images, identify the room or what that image represents, and if there's based on rules that might be set by the appraisal management company or by the lender themselves, we can set those rules to flag if an appraisal order shows that it's not meeting the minimum requirements for photo attachments. And if that is the case, we can kick that back and suggest that these photos that were in fact included in the order may or may not have been what was properly required. And in some cases, based on automation, there could be photos that maybe they were the correct room or the correct image, and then we have the ability to allow you to automatically rename those images, so this way you can pass them through the system very easily. We also have been working on the ability to identify property condition from photos that are taken or photos that might be available from the MLS. By viewing imagery, you might be able to determine whether or not a property or a room or the exterior of a home might be in disrepair, or maybe it's in better condition than either your subject or some of the comps that are being used. So in the review process, the question being, why would you use this comparable as opposed to that comparable if imagery shows that the property is not in the proper condition that we'd be looking for? We've also had some that have asked us for the ability to identify if a property might be, or that images within the property might indicate that a discount or adjustments may be required based on the property conditions. So as we move through the demo, I'll show you some examples of what we're talking about. Hopefully it makes sense. Now, I know that some of you have seen the services that I'm showing you here. Real quick, I'm going to bounce out to our search capability just to give you a brief overview of how the system works. Very easy, searching the property, identifying property details from listing and public records, and then moving forward into the report and the application. One of the identification features that you have is the ability to actually show properties side by side. This is just a feature within our application. It's not the image recognition capability, but just to give you an example of a property that has actually flipped over a short period of time, and for you to easily be able to identify, what happened here. So clearly, this property was in disrepair. It was a foreclosure, and then it was rehabbed and refurbished and flipped. But more importantly, as you move forward into the application or into the order, as evidenced from the following reports that I'm going to show you, we are on the fly identifying the photos and the condition or the type of photo that we're looking at. So easily you'd be able to see that the property images are identifying the front of a photo or front of a structure. Or if they're not identifying the front of a structure, you could easily retag them as the back of the structure or the interior of the home and so on. It sees a table, it sees the proper conditions for it to be a dining room or a living room. The system is easily and automatically identifying the features within the home to properly tag the photos as they should be tagged. And I'll give you another example of some of the photo identification capabilities. So this one is clearly flagging this property as a kitchen, and it does give you the details as Amesh had outlined earlier on, what it's seeing in that picture that is identifying it as a kitchen. So it's got the objects like the built-in refrigerator, breakfast counter, kitchen sink, and so on. So these are all capabilities that our image recognition does offer. Here's another example of a room that it's clearly identifying this as a game room, objects, billiards table. And another capability that we are offering in the near future is the ability to visually view comparables side by side by choosing properties that you might want to be looking at as comparables and distributing all of the photos into their proper categories. So all of the exterior photos together, all of the bedrooms come together, bathrooms and so on. So you can easily just page through all of the images for a different room. So this is just some of the capabilities that we've got in place that we're working on, and looking forward to moving things forward. I think, Umesh, the next slide comes back to you.
Oh, yeah. So wanted to kind of explain how some of this works in our world. Like we were saying earlier, we have primarily two stages in which we make it happen. A training stage where we train our neural networks to be able to take a set of images and learn from it in terms of how to identify objects and how to label those images appropriately, right? And once it is trained, then we put it into our standard runtime mode where we're able to take any new images that are coming in from listings and be able to give them labels on both image and object level and power a bunch of apps and APIs and data and everything off of that, right? So let us talk through some of the technologies we use here and what is and how we have done this. So TensorFlow, originally from Google and open sourced platform right now, is the one that we have built all of this on. About a decade or more ago, there was a kind of an enlightenment in the machine learning and the neural network world that we don't have to build and train each neural network from scratch. Instead, we could make a neural network learn a lot of the information and then we could use this technique called transfer learning to be able to make use of those basic learnings and add additional layers in the network to be able to do additional higher level activities, right? So that is the core concept here of making use of an existing platform such as TensorFlow, or it could be Clarify or other platforms that we pointed out in an earlier slide. Each of them provide this kind of a capability of using a foundational network to be able to build on top of that, right? So that's the core idea here, and we have taken a large set of images. We have a database of close to now over 23 terabytes of images across various properties. They're all obviously copyrighted and everything by the MLSs, but we only use it for training purposes, right? So it is primarily bits and bytes. And using that kind of a data set, we have done extensive training, and we have divided that to a training set and a testing set, using which we test how good our training has been. So we have trained ourselves on two major problem areas at the stage, classification of objects. And actually, we have done a few additional ones, but these are the ones that are currently available for folks to make use of through our apps, APIs, etc. Right? And so the step one is an image enhancement. That's the one that we spoke about earlier as an image processing step. And these enhanced images and improved images are the ones that flow into our classification and object recognition training platforms, right? And at runtime, once this training is completed, we extract these raw images, the ones that Danny was just showing in those pictures where you had a kitchen with a bunch of additional objects in there. We were not displaying the probability scores for each of them, but each of them we end up having a confidence factor attached to all of those labels, right? And we then feed this raw information into our heuristic inferencing engine, which makes decisions on, okay, if you are looking at a particular home, a particular image, and inferring it as a laundry room versus a kitchen, but we see a few additional objects in this particular image that should be really classified as a kitchen, then those are the types of decisions that are made within this inferencing engine, right? And once we go through this process, then we have finalized our inferences. These ultimately flow into an insights database. And from that insights database, we power a bunch of apps, APIs, and we also use it for enriching our data. The fact that we found there are two research lights in this particular room is useful information that may not be captured in the listing already, right? So that's the kind of information that we are enriching in our data itself, and Danny will kind of walk you through a bunch of other enrichment that we do. And we also power the apps that you just saw, like Market Conditions Advisor, etc. Yeah. Danny, if you want to just jump to the next slide, I think there are. Yeah. So these are some of the applications that we power currently. ICML Live, it's a comparative market analysis platform. We use our image recognition capability to pick the best property images that need to be included in a CMA report, right? It could be a comparable property in the area that is currently listed, which has images. We want to make sure that we are pulling the appropriate images based on an agent's specific preferences. MCA, Market Conditions Advisor, that's the demo that we just saw. And we also have an IDX capability that we power various IDX websites using our image recognition. And that is, we are able to provide these alt capabilities on image tags in HTML to support much better search engine optimization, and also be able to find similar homes, not just by using the data on the homes, but really using the information in the images, right? Aesthetically similar homes or architecturally similar homes, etc. And also comparing homes side by side using photos. That's another example that Danny just showed you all. So those are all facilities that we are powering IDX websites with, right? It's like a totally rethought, a new experience for users when they come to IDX portals. And all of these are also available as APIs. various APIs. We are happy to kind of get into the detail as needed. Yeah. In the interest of time, let me hand this over to you, Danny. Continue on this.
Okay. Some of the other things that we do ourselves for a number of reasons. So Umesh was mentioning the IDX AI capabilities. We have some users that are testing a service right now that gives them the ability to actually build a listing with imagery by going to a home, taking pictures, and identifying objects and stuff within the image for certain rooms. So this way, maybe they might be able to more easy clicking and dragging on the features within a particular room, building that listing. But for our purposes, we're enriching and enhancing our own database by capturing features within the objects in the images that we're able to, in a sense, build an additional set of data that can sit side by side alongside our public record and our listing data, which in the long run will benefit all of our customers, because there are a lot of cases where public records don't necessarily capture everything in every market, and listing data doesn't necessarily always capture everything in every market. I could only speak from example from in my market in New Jersey. Listing data doesn't typically pick up the building area, gross living area, things along those lines. Public record data doesn't pick up any exterior features of a home. So there's no information on swimming pools and spas and things along those lines. So from an exterior feature capability, we can look at the image of a home and help to classify a property architecturally or property type. Is it a ranch? Is it a colonial? Is it 1 story, 2 stories? Is it a 3-story townhouse? Potentially the type of construction materials and siding. If I was looking at some of those pictures that we were looking at before, the exterior of the homes, the frontage of the homes will in many cases indicate that there's stucco siding, that there's vinyl siding, things along those lines. We also will have the ability to look at a driveway and try and determine the number of parking spaces by the width and the length of the driveway. Aside from the garage doors, if there's 2 garages, clearly you've got a 2-car garage. However, where I live, my home, I don't have a garage, but I've got a very wide, very long driveway. I could fit 8 cars in my driveway. So to have that capability of looking at it and saying 8 parking spaces, or if there's a view, does it overlook a golf course? Does it overlook a body of water? Same thing with the interior of the home. Number of sinks. Is it a double sink in the master bath? Is that closet a walk-in closet, or is it a standard closet? Is the fireplace a gas, electric, or wood burning? Umesh had mentioned earlier the ability to look at a countertop and determine is it Formica or vinyl or granite. The appliances side by side, top freezer, bottom freezer, things along those lines. Also with basements, is it a walkout basement? Or is it a standard basement? There are stairs right in the middle of the home. That's the only way up and down. And as I mentioned, the add-ons to the swimming pool, spas, is it a professionally landscaped or does it look professionally landscaped? The homeowner has a green thumb. Does the property have a deck, patio, and the window treatments? So the data enrichment that we do, we don't commingle with any public or listing data. And if you know me, you know my thought process. You don't commingle data, because once you start commingling data, it brings all of the data that you've got in your database. The integrity of that data then becomes a question. So you keep everything segregated. And that's a third data set that we will be building at the property level as we move forward. So additional fields that would be available via our APIs. I didn't get a chance to show you the scoring capabilities in the MCA, and we could always get together and talk about that. But most companies that do property or comp scoring use very similar capabilities, because if it's an automated process, they're using property characteristics, perhaps bedrooms, bathrooms, living area, lot size, stories, proximity to the subject property, and maybe they're also using some additional fields such as price range and things along those lines. As we move forward with image recognition, we can also compare the architectural style of a home. Is it an aesthetically pleasing home? Does the house have similar siding to the subject property? Does this pool, is it an above ground pool or an in-ground pool? What kind of amenities and also condition of the property, as we discussed earlier? Does the property look like it's in disrepair? Is it truly a comparable, or should that one be disregarded? And there's a lot more features that we'd be able to use from the photos to compare, the scores of the comps that are coming back. And another item that we believe is a benefit, as we've mentioned before, the ability to look at a home before and after, because we've got the listing history on the majority of the data in our database. We've also got the image history of those properties. So in a property that you're wondering why did it sell in such a short period of time, and the property, the sale price was so vastly different from one sale to the next in 3 months or 4 months. The ability to look at a property and determine, was it a flip or was that property in default, and then it was a fix and flip. So the property images that you see here, these are the ones on the left are from the same house, the ones on the right are the same house. So you can see clearly the exterior of the home, or the front of the home, on those the first two pictures on the left, and down below, that's the same bathroom within a couple of months of one another. And then the same thing with the pictures to the right. Even though the one on the before picture on the right is a little bit dark, if you got a close-up view of that, you would definitely see that there's a significant improvement from one home to the other. And again, that's the same bathroom for those two pictures for the property on the right. So the capabilities of being able to use the imagery to easily and quickly identify, flip, default, these are some of the capabilities that we've got in the works. So that's my story, and I'm sticking to it. So I think we've reached the Q&A, the questions and answers period. So, Sakir, did you want to take it from here and gather any questions that might be presented?
Yes, there are a few questions that have been raised. So thank you, Umesh and Danny. I'll read out the questions for you that we have received, and you can take the question. So the first question is from George. What's the current accuracy level of the image classification, and how is it improving?
Sure. Yeah, let me take that. So we have been able to achieve, depending on the type of image, it certainly varies between interior images versus exterior images. So we do try to see them under different classes so that we can measure things appropriately, because the interior images become a lot more complex to classify than exterior images, right? Because the variables are so much more lesser when you look at exterior images. And on the interior images, we are at about anywhere from 85 to 90% accuracy level right now, and it continues to improve quite well. And that's our current accuracy on those things. As you were seeing some of the examples that Danny was showing there, you would have seen objects that were coming up in some of those images. For example, the one that's being shown right now, you will see that the image quality is pretty poor in the before picture. That's the third one from the right. Third one from the left at the bottom. it depends very much on the image quality. We try to increase the brightness so that we can then do a better inference from there, but sometimes the image quality might not help us do a good inference as well, right? So even those, we end up classifying them as in the remaining 10%, so that we set a target for ourselves to kind of solve it completely wherever we find an image, right, irrespective of the quality of the image. So it's an ongoing process. So that's where. And on the other hand, if the image quality is good, our accuracy is pretty high, right? We would consider it about like 95% or higher when the image quality is pretty good. So I hope that.
And if I might chime in for a moment, these two homes that you're looking at on the screen are both of them were vacant when the images were when the photos were taken. So if you're taking a picture of an empty room versus that exact same room with the proper furniture within the room, that of course is going to change the accuracy level considerably, because an empty room, there's no objects to say it's this or that. So that does also come into play. And the same thing would apply to the angle of a photo that maybe the photographer took the picture of. We can properly identify the front of a home if you're in front of the home. If you're 300 yards away taking a picture of the front of the home, it becomes obviously a little bit more difficult.
Yeah, the next question is from Stephanie, and it's a two-part question. The question is, what image labeling APIs are available today for immediate use, and what's the performance or the response time per image?
Okay. Yeah. So we have a bunch of these capabilities, Stephanie, right now. So, oh yeah, there you go. I think Danny's getting back to one of those slides here. So get labels for image. All of these three APIs are currently available. These are for a given image, you can point us to a particular URL, or you can upload an image using that API, and we would return the label as well as the objects we found within that image, right? So that's a single image kind of a call, or you can give us multiple images in one call, and we would give you back all the labels for that set of images, right? So that's one type of an API that's immediately available for you to use, and that is a kind of a generic, irrespective of the listing, the property, any other information, we can provide you that, right? But then knowing the property information, when you call something like a get listing details, and you are giving us an address for a property or a listing ID from the MLS and ask for auto labeled and auto ordered images, we will actually, based on your setup, when you become a customer, we can set up some of these core capabilities on how to auto order the images for you. If you opt to do that, then we would return on that get listing details call a list of all the images pre-ordered and pre-labeled according to the information that we discovered from those images. And similarly, that's also true for get listings by radius on a bunch of properties that you're searching. We can give you that back as well. These last two APIs are most efficient when it is pre-labeled, even long before you make these get listings by details and calls. I mean, so when you sign up for these APIs, typically we will tell you that, okay, which MLSs are you going to be signing up for, and we will pre-process those images as we get those images from the MLS. We'll pre-process, pre-label them, keep them ready for these kind of calls to come in. On the other hand, so the performance on those are pretty good. I think that was a question about performance, right? Response times. Yeah. So the response times on those two are pretty good because we would have predetermined the labels. On the first one, get labels for image, you're looking at typically per image, it should be about a sub-second per image, but then as the image volume goes up, you would expect that to kind of take longer and longer. We have capabilities to kind of parallel process some of these images on our side. So when one API call comes in, we kick off multiple parallel processes to handle all those images and give you back a label as quickly as possible, right? So you're looking at anywhere from 1 to 2 seconds per image, but then as you add number of images, does not scale linearly. We try to kind of reduce the total amount of time by parallel processing on our end. Yeah. I hope that helps, Stephanie. Yeah. Yep.
Sure. And the next question is from Mike, asking about two MLS areas that they work in, and how long will it take to label the images per MLS?
We would be able to process, in terms of just giving you volume information. If you look at a regular MLS in a metropolitan area, let us say there are about some 20,000 listings on the MLS, we would estimate that about like 20 to 25 images per listing, right? So that would take us about a week or so to kind of run through all the images and make sure that everything is labeled, pre-labeled, so that you can get accurate. I think that may be a follow-up question from what I was saying earlier. So we can pre-label them and provide that to you, but it will take us a little bit of time to pre-label. But if it's an MLS that we are already labeled for some other customer, you get the same value out of that. So everybody, that's the whole point of this economies of scale. When we are centralizing all these images in one place, we're able to give you back all these labels pretty quickly. Yeah.
All right. Thank you.
Question.
Thank you, Umesh. I believe that's all the questions we have received so far. If there are any more questions, please send them to us at support@propmix.io. And I think we can wrap up the session. A couple of things before we wrap up. I hope the session was useful for the attendees to understand PropMix's point of view on the topic of computer vision and using it in the appraiser workflow. As we had mentioned earlier in our emails, all participants today will be eligible for a 30% discount on the fee for market conditions advisor. And the discount will be applicable for contracts signed by the end of the month, January 31st, 2019. And we'll be making the webinar recording available on our website, and we will send an email to you once that is available. Meanwhile, you can reach out to us at support@propmix.io if you have any questions. With that, we wrap up this webinar. We hope you enjoyed the session. Once again, thank you for joining us.
Thank you, everyone.
Thank you.